Hello and welcome again to Mr. Jackson's chemistry class. Today we're going to talk about how to name ionic compounds correctly. And it's very important because when we make our names, they help the chemist write the same equation over and over again with the same number of atoms. And so it's very important to name things correctly. So we now remember that we have our formula rules, which is the positive ion first and the negative ion second. Our positive and negative charges must be equal. If they're not, we crisscross and make a neutral formula. And then if there is a polyatomic ion that needs another number, we put it in brackets. But if you don't add another number to it, we don't need to put it in brackets, okay? So we've gone through this numerous times, but now we'll talk about how do we name those formulas. And we have lots of formulas. And so let's just put one down here. We have NaCl, we have CaOH, one with a polyatomic that has a number added to it. So how do you name them? Well, you basically cut them in half. If you cut after the very first element, 99% of the time that is correct, okay? And then you just name the two halves. Everything pretty much has two names. And so the positive ion comes first, but positive ions do not change their name. And so what I mean by that is they use the same name that they have in the periodic table. Do not change their names. So Na, which is called sodium, whether it's in a formula and has actually an ion, it still is called sodium. Calcium, Ca, whether it's in a formula and has a +2 charge, it's still called calcium. So they never change their name, okay? And then what about negative ions? Negative ions, well, they have a name change. If chlorine gets into a formula, okay, now it's attached to sodium. Chlorine by itself is just chlorine. But when chlorine gets into a formula, it now has a negative charge, and so now it adopts a different name when it's in a formula. And so now it is called chloride, okay? And the word ide, I-D-E, means a single type of ion, okay, or element. So, but be careful here. If I put calcium with, let me go to here, I put calcium with chlorine, it is +2 and -1, so I have to add a 2 here to have a correct formula. But even though I've got a 2, that still would be called calcium chloride because there's only chlorine on the right half side. So when there's only one type of element on the right hand side, it is called an ide ion. And so that would be meaning a single type. So if I put sodium, which is +1, with oxygen, which is -2, and I crisscross and I got Na2O, this would still be called sodium even though I've got 2 of them. And then the other side would be, which is oxygen, but there's only one type of element over here, so it would be called sodium oxide. So ide at the end of any negative ion means it is just that ion alone, but there's no other types of elements with it, okay? But there could be a subscript, but it still is only one type, okay? Then we have the ite name. Well, it's easier to learn with ite and ate, okay? There are ions that are polyatomic, so these are polyatomic ions. And what that means is they have more than one element. So here, if I took chlorine and I added oxygen to it and it's an ion, and let's say it's attached to potassium, which is +1, so I wouldn't need any added numbers. This would be called potassium chlor from chlorine, and then since it's got oxygen, it'd be called potassium chlorite, okay? So the potassium doesn't change its name, but then this is called chlorite. And the word ite at the ending, well, I should say the ending, means that there's oxygen attached to the chlorine somehow. Okay? And so then we have other ones. So we have, let's go with potassium, and then ClO3. This is +1, this is -1, so I just need one of each. This would be called potassium, and the last name would be called chlorate. And the word ate means it's chlorine with oxygen, but it has more oxygen than the ite. So here it's got 2, and here it's got 3. 8 is your best guess if you don't know. So if you have an ion that's negative and it's got oxygen attached to it, your best guess is an 8 ending. So if I'm going to do that, let's just do an example. Let's say I have silver attached to NO3. Okay? And so I cut it in half. So I've got silver would be its name. And then I got to name this half, and I can pretty much guess that it's going to be something with 8 or ite at the end. I'm going to guess 8, but I'm going to begin the name with this element. So it's going to be called nitrate because that's nitrogen. So the endings 8 and ite means something with oxygen. Okay? So these mean with oxygen, and we'll say with less oxygen. Okay, but oxygen's not used in the name, it's just 8 and ite, okay? And so this one means with more oxygen. Okay? And so that's some of the most common ways to remember how to name some of these things. So if I want to really quickly show here what's going on, is if you look here, let's look at a couple of these. Here is when sulfur is by itself in a formula, we will notice that it is called sulfide. So if I made a formula out of that, let's just say I've got cobalt, which is +2, and sulfur on the other side, it would be named, I'm sorry, cobalt, that's an O. That would be cobalt sulfide, okay? That means there's only sulfur over here, okay? But if I end up having something like cobalt with SO3, because it's +2 and -2, that'd be called cobalt sulfite. And there's cobalt sulfate, and then here's chromate, here's carbonate. And see how I told you 8 is the best guess most of the time, but there are other ones. But I just want you to be able to quickly recognize that, you know, if you see 8 and ite, you're most likely talking about a negative ion, okay, or I. They are all negative ions, okay? Here's phosphate, phosphorus oxygen. So I just want to point that out, that is what, you know, you're going to use here. So I just want to show you that those are how you name things. So remember that when you're naming, go through. The last thing I need to teach you is the transition metals. Iron likes to use +2 and +3 because it's from the transition metal area. And so these are commonly using different charges. And so we have to help the reader know which iron is actually making the formula. Okay? So it's a plus ion, so it never changes its name. But let's just put this iron with fluorine. Okay? So we would have FeF2 because the 2 would come over. And since it's using the +2 iron, I would name it iron 2 fluoride. Okay? So the Roman numeral indicates which charge it is using. And so we have to be able to put that charge in the name. So a lot of times the best way to guess at which charge it's using is to just go and do a backwards crisscross. And that works probably about 70% of the time, but it does not always work. There's only one sure method, and let me show it to you. Okay? Let's say I put this iron with phosphate. And I got PO4 -3. Okay, so I would just need one of each because they're already balanced. So I would have to look at that and say, well, how do I know it's iron 3? There's a 4 there. There's no iron 4. So what I would do is I would cut it in half, and I know I would name the iron. And then I would see that there is a PO4 group. There's no brackets around it, so I'd find it on my negative ion. So I know it's got phosphate in its name. But now I got to figure out what's its charge. So what I do is I go to the negative charge, and I look at it, and there's only one. There's no bracket. So the other side must have the same charge, because our rules on formulas say that things must have equal and opposite charge. So that most likely is iron 3 phosphate. Okay? Let me do another one just to make sure you understand a little bit better. Let's go ahead and let's use, let's go with tin. And let's use the plus 4. Okay? So let's say I have 10 plus 4. And I got, let's go with sulfide. So we got sulfide minus 2. So we crisscross, and so we got SN2S4. Well, a reverse would work. But remember, we know, so this is going to be 10,4 sulfide. But I can look at it this way. SN2S4. Do a T chart. I've got 4 sulfurs. Minus 2, minus 2, minus 2, minus 2 is minus 8. There are 2 tins. So what 2 charges can add up to minus 8 and get a plus 8? Well, it would have to be 2 4s. Because I have 2 of them. So it's easy to see why it would be 10-4. So this little, I guess, rack system, you want to call it, or T-chart, would be the best way to always figure out what the charges are. But you have to be able to see a formula, and when you deal with these 4, we're going to need to make sure we put the Roman numeral in the name. And now in college, they'll do that even more. But that's what I want you to know, how to name things correctly and how to pick the right ion on the ones that have multiple charges, okay? Well, I appreciate you for joining me, and you have a great day. Blessings.